Hi everyone, this is my YouTube channel Priyanka Tutorials. In numerical analysis, our first topic is solution of algebraic and transcendental equation. In the last video, I have told you about algebraic and transcendental equations, what they are. Now, in this video, we will start solution of these equations. So, the first approximation method from which we will solve these kind of equation. First is bisection method. Second is regular falsi method. Third is Newton-Raphson method. This method is most important. In this video, we will start with this method. So this method's name is bisection method, as its name sounds bisection. That means it divides in sections. So let's see how this method works. Suppose I have an equation fx equal to 0 and I need to solve this equation. So first condition for bisection method is that our given function must be continuous in domain A to B. This is our first condition. Second condition is f of A into f of B less than 0. That means if this condition holds, then at least one solution of function fx will lie into interval AB. This is the condition. And at least one solution, actually this condition is known as intermediate or mean value theorem. By this property, function fx will have at least one solution in interval AB. Let's see how it works. Suppose this is our curve y equal to fx, and suppose A, B. This is domain. So the first thing is that this function f should be continuous. Second is that the value of function at point A and the value of function at point B, their product should be less than 0. If this happens, then the curve cuts the x-axis at least once. At least it can cut more than once. Hence, where the curve cut the x-axis, their roots appears. Hence, this is the first root. Okay. So from this condition, from this method, we will get our first approximation solution. First approximated solution, and it is obtained by A plus B by 2. So this is our first approximated solution. As x1 is the solution of equation fx1, hence it will satisfy it. So this will be like fx1 equal to 0. Now we need to find second approximated solution. For that, what we will do, the same procedure we will follow, as x1 is also the root now, so it is lying between A and B. So now we have two intervals. Suppose this was A, this is x1. Now we have two intervals. One is A to x1 and second is x1 to B. Interval is A to x1 and x1 to b. So now we will see that root of this equation fx equal to 0 will lie either in this interval or this interval. So if this, for this interval, functions satisfy this property, then root will lie in this function, in this interval. And if this in this interval function satisfy that condition, then root will lie in this interval. Let's do it. Suppose for this interval function satisfy the property this one, so it will be f of a into f of x1 less than 0. Hence second approximated root will be x2 equal to a plus x1 by 2. Similarly, for n approximated roots we can do in the same manner. So from here, what will be the interval now? A x2 x1. So on, when we will do, then it will be a x1 x minus 1 and so on, x2 x1, like this. So in the end we will get nth approximated root, and we need to find the solution until the two iterations values come same. When they come same, then we will stop the iteration. That will be the final solution or approximated solution of equation fx equal to 0. So this was the bisection method. For the bisection method, to apply bisection method to find approximated solution of any equation, we should have these two properties. The first and most important requirement is that function should be continuous. If function is not continuous, then we are not at all able to do anything. So these were the required condition for bisection method. If function is discontinuous in interval, then we are not able to apply bisection method. And if this condition doesn't hold, if suppose it is greater than 0 or this condition doesn't hold, then function will not have any real root on x axis. So these are the basic requirements for bisection method. Example of this one, bisection method, I will discuss in the next video. So if for this video, I hope this is clear to you now. Thank you.